Yeah. So as I said we are converting real life objects to code. As we said, it's code. So I want to explain some things before I begin to explain my write up. I need to explain some things. So you need to know that as you are doing such a thing, you have to first have. You can't do this kind of stuff if you are a beginner. A beginner can't do this. So if you are a beginner and you are looking for a beginner tutorial, I'll say this is not really for beginners, but you can learn one or two things that will improve you and get one or two information that will improve your skills and your hands-on ability. So this if you want to do this kind of things, you first have to have an idea of what you are dealing with. You might also seek for artwork kind of abilities too, so that you can relate with what you are dealing with. So you must have the ability of, maybe you have been a person working with Blender, tools like Photoshop, those kind of tools. So it will give you some kind of ground. So when you're about to start, not like you're going to use Photoshop, you will use, but so you can do this better and it can really make sense. We try not to use too much of that, so you can really make it real and maybe get whatever results you want to get as you need to get it. So you have to know what you want to build is, know the skeleton of it, how you want it done. So then you begin to put in whatever you want to do and you begin to build. So that's it. So, and everything you will do is all with code. It's funny, but it's possible. It's very much possible. And what are the advantages of doing this? Why are you doing this? Because many people would ask, why am I doing this? So you are doing this to aid your ability. Because let's say I'm looking for a web developer now, and I see one developer that can build a website, and as he's building the website, he can put something in the background that people can see, and as they see it, it is more like a real object. And it's not just a real object alone, it has many details on it, that if I click on it, it will bring me the results, every result on that detail, that I can go deep into it. And as I'm going deep into it, maybe I have an image, and maybe I have a face, and I go deep into the face, and as I'm going to, and I'm seeing different sections inside, to create interest of users will like it. So it's not just about liking really, but it helps it to look more better. It helps it to show improvement, and it helps it stand out. It helps you stand out. So that's why you are learning this, in order to stand out. So let's go into this explanation. The world we live in is filled with tangible objects, tables, cars, buildings, and even natural elements like trees, rivers. And one of the most fascinating aspects of modern technology is our ability to represent, simulate, or even construct these real world objects through our power, your power of code. Through the power of code, yes. From creating simple virtual models to designing interactive systems and even controlling robotic arms that build physical products, programming has made it possible to bridge the gap between the digital and physical world. But how exactly do we convert real world objects into code, and how do we construct real world like behaviors into programs? So let's dive into that. Number one, you have to first understand what you are dealing with. To understand the concept, converting real life objects into code means digitally representing them This could be a visual representation, a visual representation like 3D model or animation, a functional simulation, or both. Constructing objects with programming can range from making a simple button in a website, an abstraction of a real button, to building complex physics simulations like how a ball bounces. Okay. At its core, programming abstracts key features of real-world objects, attributes, shape, size, color, material, with behaviors, what the object can do or how it reacts, interactions, how it works with other objects. Why is this important? Why are we doing this? So you can build things like, so you can build games, characters, tools, and environments are built from scratch with code. So if you have this ability, you can easily integrate this ability into building many things. Building games. Second, architecture and engineering, simulation of bridges, buildings, vehicles. And these things are very much possible. These are things that many people have not really put much much attention to. They have not really paid much attention into it, but they are very much possible, especially now with the power of artificial intelligence. It can help you to explore different codes, different works of other people, and you can improve yourself over from there. So education, interactive models for biology, art pumping, chemistry, robotics, programming reward robots to mimic human actions, web and app development for UI UX elements, mimic physical tools, e.g. a camera app. Without converting objects into code, we couldn't have VR, AR, video games, and design simulations or AI robotics. So basic steps, how is it done? Number one, observation and abstraction. Observe the real life object, identify key properties. For a car, identify its wheels, engine, color, speed. For a chair, identify its height, material, number of legs. Simplify unnecessary details. Just simplify them and still have them in mind, but don't take them. You can just add them once you are done. So example, when building a digital chair, you must ignore tiny scratches on the wood and focus on the general shape and size. Number two, mapping to data structures. Objects are often represented in programming through classes or objects. It's object-oriented programming. So you will need that, the process of the programming, programming process. Each attribute becomes a property. Each behavior becomes a method. Okay, we have a code here that tells us about an object, that a chair object. So this is a JavaScript code using object-oriented programming. So this simple chair class captures the essence of a real chair. So number three, visual representation. So it's optional. You can use graphics libraries to create 2D or 3D models. Tools like Canvas, Threejs, Unity, or Blender helps turn code into visual arts. Example of drawing a simple chair seat in HTML canvas. Okay, so this is another code we can try out. So you can't really say you try this out, but if you are really familiar with JavaScript and game development, you would understand some of these things. For this one now, you need 2D. This one is trying to tell the browser that as we are working, that it is redirecting it, that as it's working, it should work with 2D. So, and this stuff also has 3D properties too. So people use this. They use this in animation, games, Many of all these things, like I've said. So number 4, adding physics or realism. So that is like animation. To make it behave like a real object, you might add gravity. That is, if the chair falls over. Weight in a game physics engine, collision detection, e.g., someone can't walk through the chair. Yeah, someone can't just, yeah, it must show that like real objects colliding. Physics engines like matter.js or Unity physics simulate real world physics. Real life examples: 3D printing. Designers create 3D models using code, CAD programming, or scripts. The code is converted into machine instructions. 3D printers physically build the layer by layer. Yeah. Game development. Entire cities are built in games like GTA V by coding roads, buildings, and vehicles. Robotics. We're looking at real life examples. Yeah. Robotics. Robots are programmed to mimic human gestures or animal behaviors. Example: a robotic dog is programmed to balance, walk, and jump by abstracting and constructing the way muscles and joints work. Yes. Virtual and augmented reality. Apps use code to superimpose digital objects like furniture into real-world camera views. Objects have to be coded with correct scale, position, lighting, and interactivity. Deeper techniques. Some of the deeper techniques can use deeper techniques in the scene. Some other techniques: mathematics behind the scene, geometry, trigonometry, linear algebra, calculus. Without maths, constructing, so math is going to be very, very useful if you are doing all these things, because you will, especially if you are dealing with animations, you need maths. Programming generally requires a lot of maths. But it's actually what you are planning to work on. So, and I'll actually say many people fear maths. When they hear maths, they feel like math is not easy. What I'll say is, yeah, we know there is math. We know math can be tough. But some people say something like, does one person have two heads? Yeah, we know the person doesn't have two heads. Yes, but you can actually have two heads. You can have two heads, yes, because if you collect information from another person, you are not using your information, so you are using two heads. You're not using a single head. You are using two heads. Yeah, two heads. So it's very important that you collaborate with people. That way you can easily get better information and improve quickly. Places where sounds and looks difficult, you can quickly get what you need and fill up and move faster and just focus on quality instead of quantity. Instead of how far you have learned, just focus on quality of what you are doing. So, and that's the way it would make sense. Example: AI and machine learning. In advanced systems, AI learns to recognize real-world objects and replicate them through code automatically. AI can watch a bird flying and generate a flight simulation without hard coding every wing movement. So AI also assists a lot in many of all these things. AI assists a lot. So many of the challenges here: complexity. Real world objects can have thousands of properties. So if you are trying to do something like an object many people have never seen, or maybe an object of your apartment, objects of something very complex, you would have many challenges. So you just have to learn how to walk through it. Accuracy, simulations must be realistic enough for their purpose. So it must, after walking through it, it must eventually look okay. It must eventually look accurate as to what you are trying to do. Performance, highly detailed objects can slow down programs, especially games and AR apps. So you must also work on the performance, even though it is accurate, but you must ensure that everything eventually fits in and is not too large that it will begin to affect the devices it's working on. It's not too large and it works perfectly. Maintenance, updating real world models if the real object changes. Yeah, if you did that on a website and you did such kind of thing, or maybe an animation on a website, and in real life the real stuff you animated has changed, you have to do some changes. Future of converting objects to code. Yeah, let's look at the future. Digital twins, exact virtual replicas of real world machines for monitoring and prediction. VR or AR integration, seamless mixing of real and virtual objects. Haptic feedback, programming touch sensations into simulations. Smart cities, entire cities monitored and simulated by code. Yeah, there are some cities that have, not cities, I won't say cities, but there are some things that people are doing online. They are able to build a whole city, a whole game. They build everything using code, and they build everything, put everything to code and build it up. Build everything using code. There was a game like that I saw that was built. Everything was built, everything into code. All these courses are online actually, but yeah, you focus on courses, but understanding is important, but improvement is also important. In the future, everything you interact with physically might have a digital twin coded into some system somewhere. So later in future, you might later find out that most of the things you see, or maybe many of the great buildings that you see, you will already see them online. What I mean is, many of them, as you scroll through some websites, you see them there. You see them at the background already, or you can just see an animation of some people walking, kind of. It's actually moving into it. Technology is improving every day, so it's moving. We are moving into it already. We are already in it already. So, in conclusion, converting and constructing real life objects with code is more than just replication. It is a form of digital creativity. We take the physical world, understand it deeply, and rebuild it with the logical, infinite possibilities. Yeah, of code. Yeah. Whether you are building a simple drawing of a chair or a fully interactive simulation of a flying drone, the principles remain the same. Observe, abstract, model, construct, and simulate. Programming gives us the superpower to reimagine the real world, not just as it is. So, thank you for watching, everyone. So please don't forget to subscribe. Don't forget to subscribe, like, and share. So I'll see you another time, another day. So I hope you learned something today. If you learned something